All right, we're going to find the family of antiderivatives of this function right here, and the first thing I'm going to do is rewrite this a bit. So that x to the 2.5 power in the denominator can be moved up to the numerator and the power becomes negative. And we are looking for the function whose derivative is 5x to the negative 2.5 power. And we can recall that the function whose derivative is x to the n is this 1 over n plus 1, x to the n plus 1. So let's start off simple with this term right here, and let's actually use this formula. If we want to find the function whose derivative is x to the 10th, what we can do is say that n equals 10, and then we can raise that power by 1, giving us x to the 11th, and then we can divide the function by that same power. Then what you'll notice is that the derivative of 1/11th x to the 11th is just x to the 10th. That gives us the antiderivative of this term right here as 1/11th x to the 11th power. Now let's do the same thing with this term right here. We want to find the function whose derivative is, let's say, x to the negative 2.5 power. Using this formula up here, we can say that n is negative 2.5. Then to find this antiderivative, you can add 1 to that power. See, adding 1 to that power would be negative 1.5, and then we can divide by that same power. So that's a true statement. You can check it. The derivative of this function right here is x to the negative 2.5. Of course, we also want a 5 outside of this function, so what we can do is just multiply both sides of the equation by 5. And over here, you can put the 5 out here, or you can move the 5 in here, and you've got yourself then an antiderivative of that term. And the rest is just simplification. I'm not a huge fan of mixing decimals and fractions here. 1.5 is 3/2. And then if we divide the fractions here, we're going to get negative 10/3 x to the negative 3/2 power plus 1/11th x to the 11th. And to build a family of antiderivatives there, we need to put our plus c on there. Now it would probably make sense to check this answer. In case something went wrong there with the math, let's try to find the derivative of this function. We multiply by the negative 3/2. We would reduce the power on x by 1. On the next term, we would multiply by 11. And the derivative of a constant is just 0. If we reduce these fractions, 3's cancel, the negatives cancel. 10 over 2 is going to give us a 5. Okay, so when we simplify our fractions, we get back our original function, so it looks like we did this correctly. Cool.